This quick video is going to give you a review of the properties of exponents. And exponents have three basic properties that you need to know. The first one is called the product rule. And the product rule basically says when you have the same bases, remember the bases here, in this case A and 5. So when your bases are the same and you are multiplying, you will add the exponents. So if we have a to the third times a to the fourth, what we really mean is, remember, exponentiation is shorthand multiplication. So what we really have here is a times a times a, there's a to the third, times a to the fourth power, a times a times a times a. 1, 2, 3, 4, 5, 6, 7. So the shortcut we can use is just to simply say this is a to the 3 plus 4, a to the 7th power. And the product rule applies no matter what the exponents are, whether they're positive, whether they're negative, whether they're fractions or variable expressions. If the bases are the same and we are multiplying, add the exponents. So we end up with 4 plus negative 1. That is the third power. Also note, ladies and gentlemen, the base does not change. The base stays exactly the same. Now, this one can be simplified if you are instructed to. 5 to the third is 5 times 5 times 5, which is 25 times 5, which is 125. But once again, the base does not change. That is the product rule. The next rule is the quotient rule. And we also have to have like bases when we are using the quotient rule. So once again, if the bases are the same, instead of adding those exponents, we will subtract the exponents. So let's take a look at what this first expression actually means. A to the 10th, so a times a times a times a times a, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 powers of a in an expanded form, being divided by 6 powers of a times a times a times a times a times a, 6 powers of a. Now, what's really happening here, if we think about basic division, is that we really have a over a times a over a times a over a. And a over a divided by a, is actually a form of 1. So we can very quickly here cancel a over a. It's equal to 1. A over a, it's equal to 1. We can cancel each pair of a over a's because they're equivalent to 1, leaving only 1, 2, 3, 4, a to the 4th power. So a quicker way to have written that would simply be to keep the base and subtract the exponents. 10 minus 6 is 4, a to the 4th, and we can see them right there. We did the same thing with the 10s. I won't write them out this time. The bases are the same. Subtract the exponents. So numerator minus denominator here, so 7 minus 3. We end up with 10 to the 4th. 10 to the 4th is equivalent to 10,000, a 1 with 4 zeros. Next, as I said earlier, the properties are the same no matter what the exponents, no matter if they're positive, negative, fractional, variable expression, anything. The bases are the same, subtract the exponents. So this last one will be x to the negative 7 minus negative 3. And of course, negative 7 minus negative 3, if we add the opposite, will become x to the negative 7 plus 3, which is x to the negative 4th. We learned in the previous video that negative exponents make reciprocals. So we could quickly turn this around, flip it into 1 over x to the 4th. So that is the product rule and the quotient rule. The last rule is the power rule, which I mentioned in the previous video. And the power rule is just the opportunity to multiply when we are raising a power to another power. It doesn't necessarily have to be higher, but in this case, it's a to the 5th squared. Think about what a to the 5th squared means. It really means a to the 5th times a to the 5th. And if we write it in an expanded notation, then we really could just apply the product rule to it. 5 plus 5 is 10. But of course, that's what we get if we just raise the 5th power to the 2nd power and multiply. A to the 10th is the simplified answer. The base never changes. Next, we have 3 to the 3rd to the 5th. The base never changes. We are raising a power to another power. 3 times 5 is 15. We will multiply the exponents when we are raising a power to another power. Even if those powers, even if those exponents are negative, we're still going to follow the rule. The rule is the rule. And oh, by the way, 3 to the 15th power is a really ginormous number, so we will leave it 3 to the 15th. Next, once again, the base stays the same. The base never changes. Power to power, multiply those exponents together. So if we multiply a -3 times a -2, we end up with a positive 6th power. Power to power, multiply. Follow the rules for multiplication. The base never changes. So 2 to the 6th is 64 if we reduce it. Last, in parentheses, this entire quantity is being raised to this -3rd power. There's actually 2 ways for us to simplify this particular expression. We could go ahead and raise everything to that 3rd power, following specifically, literally, the power rule here. So m to the 4th to the -3rd would be m to the -12th over 2 to the -3rd. And now we have 2 negative exponents, and of course, negative exponents make reciprocals. So really, I can just flip this whole fraction since both the top and the bottom have a negative exponent. Take the reciprocal and we get 2 to the 3rd over m to the 12th, which would simplify to 2 to the 3rd, which is 8 over m to the 12th. Remember, I've said the variables are the easiest part. The second way of doing that same problem, let me rewrite it, would have been to eliminate the negative exponent first. So if we know that negative exponents make reciprocals, I could also eliminate that negative exponent first just by flipping the fraction to begin with, and then the exponent goes from negative to positive. And then 2 to the 3rd over power to power, m to the 12th, and we still get the same answer no matter what order that we fulfill that property with. So, ladies and gentlemen, that is a quick review of the properties of exponents.